All right, you guys, starting section 5.1. We're going to break 5.1 into 3 parts. For this first slide, what I'd like to remind you guys about is a good place to start when you're asked to find remaining trig functions is start by finding x, y, and r and use the basic definitions, non-SOHCAHTOA definitions like sine of theta is equal to your y value over your radius. Once you have these, then you can just fill these things out. Secant, I'm going to bust straight away into cosine. Cosine of theta is 3/5. You know that this is going to be your x over your radius. So x is 3, your radius is 5. You could do the Pythagorean theorem, x squared plus y squared is equal to r squared, and find out what y is, but because you're given this piece of information, remember cotangent is x over y, it's already telling you the y. So now you can go and find your remaining trig functions. Okay? Don't forget all of these identities that you guys are supposed to know. All right? I realize that it's a bit daunting to remember these, but if you know these, then these questions that are going to follow in the rest of this chapter are going to be a lot easier. Okay? Here goes. First thing, when in doubt, write stuff in terms of sines and cosines. So, secant is worth 1 over cosine times cosine over 1. These are reciprocals, so your answer is 1. Okay. Don't forget the difference of square pattern. You're going to see this a lot in this section, in this chapter. So if you have, I don't know what that's supposed to be, 3x minus 2 times 3x plus 2, and if you FOIL that out, you get 9x squared minus 4. So it's a difference of squares. And remember that it factors back into something like this. So when you're staring at this, don't write things in terms of sines and cosines straight away. Just look at it as it's a difference of square pattern. So you're going to have cosecant squared theta minus cotangent squared theta times cosecant squared theta plus cotangent squared theta. If to the 4th power bothers you, how about I write it as, x to the 4th minus y to the 4th. That's going to factor. It's a difference of something squared. X squared minus y squared and x squared plus y squared. Doesn't matter which one's plus, which one's minus. Okay? It's a difference of squares. Okay, something squared minus something squared. The thing that's being squared is x squared instead of just plain old x. Okay? Now, go back to your identities. Sine squared plus cosine squared is 1. I got a cosecant. Cosecant is 1 over sine. Okay? If you divide both sides by sine squared, you get 1 plus cotangent squared is equal to cosecant squared. I've got a cosecant squared minus a cotangent squared. So if you pull this to the other side, this becomes 1 is equal to cosecant squared theta minus cotangent squared theta. Cosecant squared theta minus cotangent squared theta is worth 1. So this is worth 1. So your final answer is the cosecant squared theta plus cotangent squared theta. That's what this would simplify to. This simplifies to cosecant squared plus cotangent squared. This next one is real similar. It's a difference of square pattern. So it's going to factor into sine squared theta minus cosine squared theta times sine squared theta plus cosine squared theta. And you should remember the basic Pythagorean identity. Sine squared plus cosine squared is 1. So this is worth 1. So it becomes sine squared minus cosine squared. Okay. That's the end of this section. I haven't given you every example of every single type that you got. Just remember, when in doubt, rewrite things in terms of sines and cosines like this. And then if it's something that can be factored, try factoring it. And then replacing stuff from these identities and let it cancel out.